So we have this data mining. The first of all, that why do we study this data mining? Thing is that we know that we have a large amount of data. Say huge data is available, but the thing is that what we want is that what sort of knowledge we can extract from that data. So data might be in form of databases, data might be in form of data warehouse, data might be in form of say big data also. So whenever we say data mining, don't be confused. This has nothing with the storage of data, extractions, or you can say the pattern generation out of the data. Okay. So database and data mining is two different things, or say you can say that database and data warehouse is somewhat like used for data storage. Uh, Certainly, what we had in form of databases is that earlier it was file systems where actually we were storing the data into files, but we have experienced so many like you can say limitation in that searching was very difficult, even updation was very difficult, because if the data is appearing in multiple files, then updation requires multiple file access also. So and tracking of the updation or manipulation is was actually very difficult. So we moved to databases, and certainly from early say in 70s we have some DBase, and then later on we have COBOL, then we have Visual Basic, then we moved to so many advanced databases like Oracle in 90s, say DB2, and then SQL Server. So, if you look on the evolution, then you'll find that slowly we are just updating the facilities, or you can say the manipulations uh, facilities of the uh, databases. So that was the that was the need, and obviously databases are you can say important in the case that databases can handle the redundancy also. Database can handle the security authorization. It can also handle lot many things which is required for data manipulation. Okay. Then later on, it was actually realized that uh, we are actually having like all databases can handle the application oriented data manipulations. Application oriented means like suppose you are talking about something like library information system, you can talk about some say payroll system or something like that. So when you look for such, where actually you are doing some sort of day-to-day activity on the data, then that actually evolves. So the database evolves on the applications. So later on, it is realized that there is no such storage or database which can actually handle the subject part. That means if I'm interested to have say data storage which can talk about one subject, say suppose for example if you talk about your triple IT Allahabad, then I'm interested to talk about only say student. Someday I may be interested to have faculty members, someday I may be interested to have some other subjects also. So when I say subject, that means I'm just concentrating or I'm just focusing on one particular subject, and all the data which I'm looking for is related to that subject. So certainly in that case, we'll be avoiding or say ignoring uh, some of the data which might be useful or important in case of say application, but it might not be useful for the subject. So that was the view, and this warehouse came in picture. Certainly, the modeling and other things are very much different from what we have in databases. Say in databases modeling, you know that we use ER model, then we make use of say relational model, and then we move forward to have say there are so many referential constraint we have, and then we have some constraint in form of triggers, assertions, and functions. Then we move on to have normalization also, where we look for several set of normalization, say normal forms, or we wish to have any one of the normal form to be uh, verified or say satisfied by the particular data, particular databases. So that was the case in was realized that if I'm looking for subject, then I'll be interested to store the data which is historical in nature. Historical in nature means that I can say that if I'm looking for data for students, then certainly student data will start from 1999, where actually when IIIT was actually you can say conceptualized and opened for the students. So from that point of time till today, we have several kind of data which is related to students are available. And obviously in that case, we'll be having the different media also. Media means certainly it is not necessary that whatever data format we are using right now is same what we were using in say in 2000 or 2005. So it may be the application programs may be different. It may be the case that the way we actually store the data was different. It may be the case that format of the data is different, like data types were different, data size were different. So there are so many heterogeneity actually comes in picture. So certainly warehouse is actually the process of integrating the heterogeneous sources of the data to have a single centralized data storage, and which actually evolves around the subjects only. So that is what the warehouse actually does for us. Then later on we move forward, and obviously certainly in case of warehouse we may not be able to have this normalization part, because when the moment we yeah. I think we had a discussion with semantic data analysis part, the teacher, and actually this particular slot is for us right now onwards. Okay, okay. So we'll be having data analytics in this case in this slot. Okay, we had discussion for that. It's fine. Okay. So uh, uh, I think we were talking about come to the point, and then we were talking about data warehouse, then the modeling. Since normalization, the fully normalization criteria fulfillment is not possible, so we go for unnormalized data modeling. Namely, we go for star, snowflake, and fact constellations. Certainly, this is not part of your syllabus, but if time permits, then we'll discuss a little bit of that only. That also. So what we have is then obviously these are big data and all came in picture, where actually you talk about velocity, variety, and volume. And in all these three cases, we are looking for high, you can say degree of volume, high degree of velocity, and high degree of variety. So we talk about when you talk about something like 100 terabytes or maybe more, then we normally we refer it as big data. So how to do that? So now the question is, certainly we are able to capture the data and store the data, say from small data to big data or maybe large data as well. So what actually requires out here is that can I do some sort of mining on the data, and can I have some pattern out of it or not? Okay. Pattern means something which is new. That means that is not known to you. there may be two way of looking on this. The first way is that you can, first thing is which you can say that that just a minute. Okay. So what we have is that there are two ways of looking on that, whether the knowledge when you talk about. One thing is that is not known to you. That means something is hidden in the data. Okay. And I'm looking for that hidden knowledge to be find, like we can find out the knowledge by using some sort of methods, algorithms and all. There are another thing is uh, the knowledge is there, but you are not aware of. You are not aware. So when I say that knowledge is there, but you are not aware, that means the data itself is having direct knowledge, but we could not see that particular knowledge. So that means it is not known to you also. So that means if both way I can find out something which is not known to us or known to any of the person involved in that domain, say like if I'm, when I say domain means I'm talking about top management to the low management, that nobody is aware of that. So such finding is actually is the task of the data mining. Okay. So our like flow will be like this, that certainly just we have discussed that why do we require this data mining to be studied, then what is data mining, then certainly on what kind of data you can do this mining and all, then we'll be going for data mining functionality. The question always be there that are all the pattern interesting, because when you look for pattern generation you will be generating a very high number of patterns. When I say high number means that means it is not only 5, 10 or 50, you may be generating in hundreds, 200s and thousands also. So it is always important that out of that particular those patterns, which one is interesting for you, so that finding is also one issue in this case. So obviously classification, then the issues of the data mining. Okay. These all are actually the thing is when we say that what is data explosion problem. So obviously you can see that automated data collections tool and mature database technology lead to tremendous amount of data stored in databases, data warehouse, and any other information repositories. Okay. So certainly we are starving for the knowledge. Then the solution is that I can go for data warehouse and data mining. Okay. Later on, you'll be able to do that. That the mining could be performed in any type of data, which any type of data, say any type of databases you can consider, and I can we can actually apply algorithms on that. Okay. So that is what we do. If you look on evolution, then you'll find that uh, in 60s and 70s, actually this databases actually evolves or evolved. So you can see that 70s relational data model, then relational DBMS implementations took place. Then later on in 80s, we have some RDBMS, then we have advanced data models, maybe object oriented, then extended relation, then application oriented DBMS, say spatial, scientific, engineering based, all actually evolved in 80s and 90s. And then in mid of, you can say, after 90s and in mid of, like in between 90s and 20s, you can say the data mining and data warehouse actually came in picture. Though it was actually conceptualized earlier also, but like actually the mass has not accepted that particular part, not realized that this will be a very important applications, because during those days very small databases or a small data were actually stored. So nobody realized that we require some sort of huge data storage, or maybe some sort of mining techniques which can actually will be applied on any amount of data. So that was the evolution part. And certainly after 2000, all these data mining, warehouse, big data, and all type of databases actually becomes very important in all the domain. So there are some synonyms of the data mining. We call it as KDD, which is also referred as knowledge discovery in database. We also call it as knowledge extractions or data pattern analysis, data archaeology. We may call it as information harvesting. And sometimes in management domain, we call it as business intelligence, because it actually gives you intelligence doing business. Okay. Applications, name any applications, like in all cases, it will be applicable, whether it is sort of forecasting you look for, or you may be looking for some customer based analysis, or say some customer relation management, some sort of target marketing. It is applicable in, say, bazaar like Spencer, Big Bazaar, or Walmart. Like this market basket analysis is based on that. We'll discuss it in detail all about this. It is also very much important in case of fraud detection or management domain. Certainly, text mining is one thing which actually evolves and evolved very rapidly. And we are, I think nowadays, we are actually doing a lot of analysis on web data. It may be a social network data, it may be a email data, or say news, documents, so many things came in picture. Okay. So I'm not going in detail that what we are doing in market analysis or management. I think these are just the snapshot where actually the mining could be an important tool for knowledge extraction. Okay. So whether it is customer profiling or identifying customer requirement, then various multidimensional reports we also look for. Obviously, we make use of mathematics, statistics, so many whatever tools which are available to us can be used in this. So it is also used for corporate analysis and risk management, fraud detection and management. So you can see that it is used in auto insurance, money laundering, medical insurance, all. I think everybody is actually these days are experiencing all these. Okay. So these other applications, like you can see that a lot of mining is done on IPL tournament, like to have a knowledge about the teams which are actually playing in IPL, individual players, like just analyzing the pattern of batting or bowling, or teams strategies. All these are happening and people are actually contributing also. Not only in IPL, lot of things have been done in case of basketball also. I think NBA, if you look on, then it has been very significant work has been done to identify the players and their strategies and all. Okay. So lot of applications. Certainly people are actually using it in astronomy also. And then there are something like internet waves of, which is actually a IBM based, which applies data mining algorithm for analysis. Overall, when you look for the entire process, it looks like this. Uh, what we have in this is that this part is actually the data warehouse part. Okay. What we have is these individuals are actually the heterogeneous sources of the data. Say, it may be files, it may be a database file, it may be a some sort of some sort of Java file which holds the data also. So these heterogeneous sources of the data can be cleaned, transformed, and integrated, which becomes your data warehouse. Okay, so this up to this part is actually data warehouse. So in place of data warehouse, you can make you can actually use DBMS also. So that is not a problem. Okay. So any database you can use, whether it is spatial, multimedia, or say object relational or object oriented, any type of databases can be used at this level. The important part in this is the how to get the task relevant data. That means what you have is you have data D, and what you have some problem, say P you have. So it is not necessary that this problem P requires the entire data D. Rather than it may require a sub data of D as D1. The question is how to get this D1. So obviously you will have to formulate a complex query for this. No? So that is what we call it as data mining query language. Okay, this is actually used. So this is a complex query where actually we specify all our requirement and will be fired on D, and we'll be getting this D1, and then your algorithms will be applied on this D1, and then you'll be getting some pattern out of it. Okay. So this is what this part actually, the upper part actually explains. So that means that at the lowest level we have data. Then certainly you'll be given some sort of problem. Say I'm looking for example, I'm looking for some sort of data, maybe between say last 1 year data. And in last 1 year data, say if you look for car sales, then I'm interested to know that what are the volume of say X, say you can say X car sales data. Maybe color I'm interested in red, maybe interested in some model. So I may specify some problem that I may require data for this last 1 year, that what is the pattern of customer acceptance for model X having color this, or maybe say some other constant you can actually fire. So if I'm like looking for such problems, then certainly what we do is that I have a huge data which actually uh, is having all type of data of sales of all the cars or maybe all the models. So I'm maybe interested to find out the data which is relevant for my problem. So I'll be going for task relevant data in that case. Then we look for that what algorithm to be applied. So data mining is actually the study of algorithms or methods which will be fired on the data and it can generate pattern out of it. That is what data mining is actually talking about. Okay. So this part is actually significantly talks about algorithms. Okay. Uh, my writing is not proper because I'm writing on writing pad. So maybe by practicing, I'll be able to write it in proper way. What and then this part is the question is that you have generated pattern, say in hundreds or thousands or maybe in more also. So out of this, few may be interesting. Okay. So how to get that interesting patterns? And that is very you can say important issue in this entire task, because getting interesting pattern is very difficult. So certainly we'll have to specify some of the things through which I can extract the interesting patterns. Okay. So whatever you declare as interesting becomes knowledge. And that is what the last thing is, that this talks about knowledge, is that the interesting patterns becomes my knowledge, and that can be given to the upper management for decision making. Okay. So this is what the entire flow will go. So what I'm just summarizing it, that I may be interested to mine the data. Data may be stored in database or maybe in warehouse. Databases, certainly you know that it is actually application oriented. So whenever we consider the database, certainly it might be related to, say, maybe library, finance, or say some payroll, maybe say some other like sales of sales of the particular agency and all. So such databases could be part of my task. Or there may be a case that already warehouse is in place, or you have to go for the warehouse creation. Warehouse is actually a task of integrating the heterogeneous sources. Certainly some sort of cleaning transformation is required, and then we integrate it as warehouse. So, and obviously task relevant data I can extract from either from warehouse or from databases. So that becomes your task relevant data. The moment I get a task relevant data, I'm having a set of algorithms. Like if you look on data mining algorithms, you'll find that there are algorithms which is related to association mining. There are algorithms which is associated with, say, classification problems, predictions, then clustering. And in each category, there are again set of algorithms available. So out of that, which one is prominent or which one is useful is again the task of the, say, analyst, that how to judge that which algorithms to be applied or which algorithms is suitable for my task. That is again an issue in data mining. Okay, these are the issues which actually comes. What we do generally is, it is hard, it is difficult to define or say decide that this particular Y algorithm is useful. So what we do is that instead of selecting any one algorithm Y, we certainly, in most of the cases, what we do, if you go for practical implementation, so all, even industry or any institution or organization, what they do is actually they considered a set of algorithms of similar nature. Similar nature means that doing the same task or same level of task or same type of task. And then we apply the multiple algorithms on the data, and then we try to analyze the accuracy and other things, errors and all. And based on error calculations, accuracy, and there are so many other parameters which you can consider, we can actually decide that which one is good for my data or for my pattern. And then the whatever is by comparing all these algorithms on that data, the implementation of these algorithms on that data, then the most optimal one will be considered, and that results may be evaluated for pattern, interesting patterns, and then out of that it becomes knowledge. So that is what KDT process talks about. Any questions you can ask me? Okay. So since there is no questions, so I'll move forward. Mm-hmm. Mm-hmm. like so you are looking for the difference between the warehouse and database you're talking about. What difference you're looking for? Like, what is your question exactly? Can you repeat your question? Hello? 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 Hello?
Yes, sir.
What is your question? Can you repeat?
आवाज
Yeah, you are audible. Am I audible? Ha. Okay. So can anybody can repeat his question if possible? I think what he what I can get from his question is that he is asking that if the task relevant data requires a query. Yeah. Hello. Okay. Uh, the database and warehouse, as far as retrieval is concerned, there is no difference because in both the cases you'll be using some sort of query language. Uh, it is not necessary that always you go for SQL and all. It may be anything. Like it may be through any program you can do that. Any language you can use that. See, always remember that data mining never recommends a particular set of languages or applications for their work. What data mining actually requires is that these are the functionalities we require. If any of the software or any of the languages can actually provide these functionalities, that becomes my mining language. Okay, so that is so be clear that there is no specific mining language is the constraint. Okay, any language, any software, any packages could become my mining language, provided that that particular software package or language should provide all the functionalities which I require for my task. Okay, so this is first thing. Next thing is your question is that as far as querying warehouse and querying database is almost same. The what difference would be there, as I told you, since I did not discuss in detail the warehouse part. I think most of you are aware of databases. You know that databases is nothing but it's a collection of tables. Table is a collection of rows and columns. Columns always corresponds fields or attributes, whereas rows are actually corresponds the records. So these are what databases database you can see formulation is there. So whenever query you talk about in terms of databases, then you always specify that these are the set of the tables I'm looking for, and from these tables I'm looking for these set of attributes, and I'm firing some conditions. Say maybe if I'm talking about some account, then I may be interested to fire the condition like balance should be greater than 5,000, or I'm withdrawing some money, or the the all account holders should be from Allahabad, something like that. Like there are so many like many constraints you can always fire in terms of conditions, in terms of restrictions, anything you can do that. So that is what query construct talks about. Now the question is, what difference actually comes in picture when you talk about warehouse? Because in case of warehouse, there is no table and other structure is there. In place of table in warehouse, there is a structure of dimension is there. So the warehouse is actually is a collection of dimensions. Okay. So and there is fact. When I say subject, say if I say that student is my subject, so a student becomes my fact. And then like it looks like this. Let me tell you. No, just a minute. It looks like this, that say if I am saying that the student is my subject, so this becomes my fact. I'm talking about warehouse, okay? Then there may be several dimensions, say D1, D2, D3. These dimensions can contribute in this for this subject. These dimensions could be anything which is related to students. So these dimensions, I can say this is nothing but the personal info. That means personal information. This personal information requires, let's say, name, address, phone number, and all. So this is my first dimension. So I'm talking about personal information, which is actually a dimension of the student. This dimension I can say course. Now this dimension will actually talk about the course which that particular student is related with, and maybe all other useful information which is required for that. Other dimensions may be related to something else. So when you talk about warehouse, the warehouse construct is actually talk about a fact and the dimensions. So whenever you write a query to getting the task relevant data in case of warehouse, so instead of table, we actually specify dimensions. Okay. And then within dimensions, I can specify that these are the things which we require for my particular problem. Okay. So that is the difference. Rest, as far as query is concerned, it is almost same. Both requires a complex query to be fired. Uh, the choice of your language or package or query language is always be with you. You can choose based on your, you can say, your knowledge and your skill set. So that is not a problem. Fine. Is that okay? I think fine. Okay, fine. So next part is this. This is this actually talks about that how this data mining and business intelligence is actually interrelated. Okay, you can see that there is DBA, database administrator is there. Then there is data analyst, there is business analyst, and there is end users. So end user is nothing but it's some you can say top management who actually responsible for taking decisions. Okay, so what you have is you can see that the below is actually where actually the data source you are talking about. So database administrator is responsible for that. This OLAP is nothing but this is online analytical processing. So this is warehouse is referred as OLAP technology. Okay. So we have data warehouses and data marts. Data marts is actually the subset of warehouse. That means a task relevant data when you retrieve that becomes your data marts. Okay, fine. Then you are talking about some statistical analysis, querying and reporting. Okay. And then data mining where actually you look for information recovery. So this particular part is by the data analyst. Okay, fine. This set is done by DBA. Then business analyst is responsible for data presentations. So that means technical person can always do the technical part, but as far as decoration of this, the output of your technical evaluation will be done by the business analyst. So the visualization will take place, and then the best can be presented to the end users, so decision makers, and where actually you can take decisions out of it. So that way, this data mining and business intelligence is very much interrelated. And sometimes in case of management domain, we always refer business intelligence, this particular data mining field. Okay. The architecture is looking very simple, that you have some sort of graphical interface where actually you are putting your queries, you are putting your problems, you are doing your task and all. So obviously you can see here that the architecture says that I can have a databases or I can have a warehouse. Certainly, data mining engine is there. So there is a metadata also, which is a knowledge base. So we have a data mining engine which is responsible for executing all the tasks. Then we have a pattern evaluations, and ultimately it goes to the user. So this is a typical architecture of mining system. Okay. Uh, Already, I think I have discussed that any kind of data you look for can be used or may be used for your mining task. So it is not exhaustive in nature, but whether it is relational data warehouse or transactional databases, uh, advanced DB or information repositories like object oriented, object relational, then spatial data, then time series data and temporal data you look for, text, multimedia, heterogeneous databases, or any sort of www World Wide Web data is there. You can actually do the mining on such data. Can anybody can tell me what is this transactional database? Anybody out of any idea about transactional database? Since you have done your database, I think probably you have done MTech might have done in BTech, whereas BTech might have done in maybe in fourth semester or third semester. Any idea about transactional database? Okay. Uh, okay, fine. Bank data could be one by one. Please. Yeah. Okay, fine. Anybody else? Yeah, please. Yes. You're audible. No. This has nothing to do with what you are talking about. This is not a transaction processing of your database. This is a transactional database. I'm talking about some data which is transactional in nature. Let me tell you, I think a bit of confusion is there. I think most of you have gone to this Big Bazaar, isn't it? So what do you do actually out there? You actually go and you take a basket, you put some items based on your list, and then once it is done, you go for billing. Once billing is done, you are given one bill having some sort of transaction ID, having some sort of set of items, having some prices and all. So this particular data, which actually you are having in Big Bazaar, can have, I can say that, say some student has gone for this. So transaction 101 is say have taken the say items like A, F, H, G, K, something like this. So and then you have transaction 102. So each of these transaction is referring individual customer. So that means suppose 5 of you have gone to Big Bazaar and all of you have actually purchased your own set of items, then each one of you will be treated as one transaction for that particular Big Bazaar. And your item list will be, say the first customer has bought A, E, H, G, K. These are items. This could be brush, surf, or maybe shirt, maybe anything could be. So when we store the data in this form, where actually one column corresponds to the transaction ID, whereas the other column is actually what has been done in that transaction. If such data we maintain, this is referred as transaction database. Okay. So not necessarily that only Big Bazaar or say Spencer or Walmart could be the part of the transactional database. Even in some cases, I can say that fine. I can say that say I can make transaction as documents. That document D1 is one transaction, document D2 is my another transactions, and in D1 there is what W1, W4, W6, something like this. In D2, in W2, W4, or say W7. So what we are saying is in document D1, these are the prominent words. Document D2, these are the prominent words I'm looking for. So this again becomes transactional database for me, where actually the transactions are actually the individual documents, and whereas words are individual items of these documents. Okay. So somewhere during the analysis, we are interested of such databases also, and these are prominently used in case of text mining also, or document mining also, and in case of say market analysis also. Because let me tell you that when Big Bazaar is logging your data in this form, they are actually using this data for a future demand, or say inventory management, and lot many things they do it. So a lot of mining process involves when you talk about. Normally, we do not realize that what we are doing in Big Bazaar is actually scanned. That means your baskets are always be scanned. Okay, and based on your basket, they upgrade their demands also. Based on your basket, they upgrade their, or they actually change their inventory also. They, based on your basket, they actually they do self management also. So we'll talk about more on this when we'll go for some mining tasks based on transaction database also. So hopefully this is what I think spatial databases, temporal databases, you know that when we talk about some sort of time based data, or some where actually place is important, then we have multimedia where actually we look for audio, video, images and all. Text database is well known. Heterogeneous, where actually different form of say data types are there, or different form of attributes are involved, or different form of say databases, small databases contributes one integrated databases involved. Okay, so that is what we do it. uh, as far as database functionalities are concerned, see, today I'm just giving you some sort of idea that what actually we are doing in data mining. Certainly, in all these functionalities which you are looking on, each actually contributes in form of one chapter. Okay, it's like association will have a one complete study. Then we have classifications. Then we have clusters, cluster analysis. So all these actually will have us another set of algorithms, and then individual chapters will be there where we'll study in detail. Okay, so these are actually data mining functionalities, say characterizations, discriminations, like I may be interested to summarize, or may be interested to have a contrast data characteristics, say dry versus wet regions, or maybe say high budget customer to low budget customer, or maybe high budget customer versus medium budget customers. So I may be interested in such contrast mining statistics. Okay, association is very much important, because this actually association talks about correlation and causality. What we are like, for example, if you look on this, what this particular part talks about. I'm not cutting, actually my pen is not working well. This is underlined. uh, what it says is, this is one association rule which talks about that a person X, this X is a person, is having age between 20 to 29, and this is end, and that person X is having the income between 20,000 to 29,000, then this is the association. That means these two together can lead to that person may buy a personal computer. So this particular association rule is maybe the outcome of your analysis. Okay, and such patterns or such rules could be part of your association rule mining. Okay, so we generate lot many, and out of that, based on accuracy, we accept these association or may reject also. So it depends on what accuracy these particular association rules are having in the data. So out of data, we formulate or we actually generate the rules, and then different set of data, we test the rules. If it actually having the particular some sort of say threshold accuracy level, then we accept it, otherwise we reject it also. So this is what association talks about. And then classification and prediction is again the thing is that certainly what we have is you can say that suppose you have data points like this. Okay, now these are the data points. Now what we have is that say it is given that we have class C1, C2 and C3. Okay, so what we'll do is I'll map these points into these classes depending upon some sort of say what you can see that class properties. Okay, so depending upon those, it may be in form of rule also, it may be some sort of criteria you can define, some sort of like classes must have some sort of property. Like I can say that suppose C1 is all A plus holders in case of student, C2 is all A and B plus, C3 is below B or below B. So if I say this, then what is happening is I can say that C1 means greater than equals to 90%. This means it is actually you can say that in between 80 and 90, or say 70 or 90, and this is below 70. So below 70 is this, between 70 and 90 is this, above 70 and this is this. So these three rules I have. Now if any new sample comes, say some value comes that 89, you know that this 89 is actually falling in this, so I can assign this value to class C2. So similarly, based on the domain of the data, there may be some sort of class properties, and then I can map these particular individual data to these classes. And there is no you can say that it is not necessary that all the data will be mapped in these classes. Okay, it may be the case that there are few data which may not be mapped. Those data is referred as noise. Okay, now the question is, what is classification and what is clustering? Actually both is having the same work. Both the clustering and classification is actually mapping the data into classes. Only the thing is that in case of classification, classes are known to the user, whereas in cluster, classes are not known. This is the difference, and that's why classification and prediction is referred as supervised learning, whereas cluster analysis is referred as unsupervised learning. Okay, fine. This is what. So what is happening in this case is, let me tell you. What is happening in this case is that we have classes known to us, and then we have data D. Certainly data D, there are set of points which can map to this. There are set of points mapped to this. There are set of points mapped to this. What is the role of the classification is that finding out this particular mapping. That means what rule this particular mapping is actually governing. So that rule finding is referred as classification. Okay. Whereas in case of clustering, I have data like this. So I am not aware of the number of classes or a class. What I'm doing is that in two-dimensional hyperplane, in hyperplane, what we are doing is that I found that these data are very close. These data are very close. These data are very close. These data is very close. These data is very close. Okay. This data is, so I can say that the data can actually form five clusters: one, two, three, four, five. Yeah. Certainly, you can say, sir, why not three? That these two can be merged together. That can be done. So, depending upon the closeness of the data points, I define the clusters. So, then that is why what we call it as cluster analysis is referred as that it is actually you are trying to minimizing the intra-cluster data distance, and whereas we are maximizing the inter-cluster distance. That means what I'm saying is that what I'm looking for is this distance. I'm trying to minimize it. As close the data points will be, the good clusters will be there. Whereas these two clusters, as far it will be, it will give you the clear picture of the clusters. So that is what clustering talks about. So it is unsupervised because classes are not known. Data itself defines the classes. Okay, that is what we do it. So obviously we have a trend and evolution analysis. You know that like in time series data, we actually do all these. We actually we make use of regression also. We make use of similarity based analysis also. We'll talk about how to what are the data types which can actually be used for similarity based analysis. So that we'll do. So I'm just summarizing it that if you look for data mining, then it is a confluence of multiple disciplines. So it is database technologies, statistics, visualizations, information science, machine learning, and you can add other disciplines also. And obviously it is applicable in almost all the domain which you can think of, whether it is bioinformatics, whether it is biology, whether it is chemical field, whether it is prediction, forecasting, stock, or any you just name the domain, you will find that this data mining is very much useful. And obviously tools are that there are algorithms which is in place and which can be used for the mining task. Whereas certainly the statistics, mathematics, and all probability, all these tools actually is used for you can say for the mining purposes. Okay, so it's a confluence of almost all the disciplines which talks about IT, computer science, mathematics, and other things. Okay. So as far as these are a multidimensional view of data mining classifications, which you can see that, as I told you, that all the databases can be mined. As far as knowledge to be mined, we can do characterizations, discrimination, association, classification, clustering, and all. Technique, it can be the database oriented can be used, data warehouse, machine learning, statistics, all can be used. Applications, name any applications, it is applicable. So overall, it's a very important tool which is widely used in today's world. Okay, so you cannot ignore this part. There are major issues in data mining. So obviously you can see that mining methodology and user interaction is also referred as one issue, because when, like, obviously we have mentioned that only data analysts are actually responsible for such tasks to be carried out. So it may be the case that data analyst might not be aware of the background or may not be aware of the domain. So it is very important that user should interact with the analyst, and analyst should also talk with the user that what is your domain and what domain requirement is. So obviously that is very important. Sometimes you can say the user can give you a data which is incomplete in nature. So or maybe there is a possibility of noise also. So obviously analyst has to handle the noise or complete the data, and obviously completion could be done not 100% you can complete the data, but certainly there are things which can be done, like we may make use of some mathematical formula, statistical formula to fill up the missing data also. Okay, so filling up of the missing data is an important task for the analyst. Obviously, as I told you, that is the interestingness problem, which is actually related to pattern evaluation, is still issue, and it is not very clear cut that how to get that interestingness part or capture this part. Performance and scalability, certainly not all the algorithms will be scalable in nature. Scalability means that when I say say you are talking about algorithm A, so whether this algorithm might be useful for a smaller size of the data, might not be useful for the larger or say big data sort of thing. So efficiency always depends on that what is the you can say the area where actually you can scale these algorithms. Okay, certainly there are ways of handling, like there may be a case that some algorithms might not be useful for the large data, but we can make it, like we can apply some sort of distributed and parallel processing. We can go for big data framework, or we can go for say framework like Hadoop or Spark, where actually data can be distributed among the terminals, and individual terminals can execute the algorithms. But these setups require some sort of complete planning also, because it is not easy to implement in all the cases. Okay. So we certainly parallel, distributed, and incremental mining methods are always welcome, and we have certain setup is available. Certainly you can go for some new to be evolved. Okay, so issues related to the diversity of the data types is that certainly you are handling relational and complex types of data. Your also information are coming from heterogeneous databases, or maybe some from say internet and all. Obviously applications of discovered knowledge when you talk about, then there is domain specific data mining tools, intelligent query answering, process control, and decision making. So all these actually you have to specify that in what domain a particular set of problems is falling, and accordingly you have to go forward for that. Okay. Still the issues are there in terms of data security, integrity, and privacy is concerned. Though I think there are a lot of things in literature also, where actually we have done a lot of work in terms of data security, integrity, and privacy. It depends on how critical the data is. You can go for the security measures to be applied on that. Okay. So for today discussion, we can summarize that data mining is actually a discovering interesting patterns from large amount of data, and a natural evolution of database technology in great demand with wide applications. Uh, it entire process includes some data cleaning, data integration, data selections, transformations, data mining, then pattern evaluation, and obviously knowledge presentation. Okay. It can be like mining can be performed on any type of information repositories. As far as functionalities, we have discrimination, characterizations, association, classification, clustering, outlier, and trend analysis we can perform. Okay. So we have seen that some classification of mining systems and major issues in data mining. So this is what we have done today. Uh, so it is this actually uh, 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 probably completes the introduction that what is data mining, why do we study data mining, what is the importance of data mining, and what are the things involved in data mining. Okay. If you have questions, please ask me.